In solidedge version 20, we want to take a look at a great new tool for 2D graphical engineering problem solving called goalseek. Goalseek enables us to perform 2D what-if calculations in combination with 2D parametric geometry, mathematical formulas, and variables and part properties. So in this first example, this is a very simple example. What we want to do is determine the area of this rectangular profile. So if we go up to the inspect and we go to the area command, the first thing to notice is that we now create an actual area object for the particular area rather than just give you the area dimension that's not really useful for anything. So by accepting that, you can see that it builds this hatch pattern. It also gives us the center of mass and the center of inertia. And if we look in our variable tables under Tools Variables, you'll see that there's a new entry in there called area. It's giving us that area in the variable table. So now if I come down and I want to create a callout, for instance, I can create a callout to that particular area using the property text. You can see that we have the new option for variables. I want to click the area. And so we just want to build a note that says the area is equal to this extracted value. Change the text height to make it a little bit larger. And you can see that this is dynamic. As I change this dimension, you can see that that area is going to update automatically. And so area is a driven dimension, meaning it's being driven by the width and the height of this rectangular profile. And so what we want to do is run the goalseek command. And so what we want to seek on is a particular area. So we select the area from the goal variables. Again, these are all of the variables that are driven dimensions or driven values from the variable table. And what we want to do is select a target value, meaning we want to adjust some other dimension to reach a target area in square inches. So in this case, maybe I want to find 21 square inches. The variable I want to change, we can select a dimension, height and width in this case, or we can pick the actual dimension using this option. So I select the dimension I want solidedge to change to achieve a target value of 21 square inches. When I accept that, you can see that solidedge automatically adjusts that dimension until it reaches the target value. Now obviously that was a very simple example. However, what if I wanted to change that target value to 35.75? This is a little bit harder calculation for us to just do in our head. So what we could do is again select that dimension to change, and this time I want to change the height. And you can see solidedge was able to find the dimension needed to achieve that area of 35.75. So let's look at this in a more practical example. So what I'm going to do is open our AMF dough mixer assembly using a configuration. So here you see we have a 2D sketch that's driving the location of the 3D components. First thing I'm going to do is just come in here to the profile for my sketch. And I want to show only the sketch, hide the 3D components, and you can see that I have all of these dimensions locking down my 3D sketch. One thing I want you to notice is this dimension over here to the right. And if you look at the name for this particular dimension is the tension or adjustment, meaning that that idler is going to move along that line to adjust to the particular belt length. So going over to the layers, we're going to show only on the belt layer. And again, using that area object, we're going to come into the inspect and place that area object and build that in the variable table. One of the components that we get also with the area is the perimeter. So if we look in our variable table, extend this over so we can see the names. You can see that one of the variables is the perimeter. In this case, perimeter is going to equal our belt length. So I'm just going to rename this particular variable to belt length. And currently it's 177 inches. And so return back to the top level assembly. I'm going to reapply a model view to turn on our 3D components. Now what we want to take a look at is how we can use goalseek to modify that 2D sketch and drive the location and size of our 3D components. So again, running the goalseek command. The goal variable that we want to change is the belt length. This is a driven dimension. Remember, it is the perimeter based on the dimensions of the 2D elements. You can see the current value is 177 inches. I want to use a belt that's 185 inches. And what I want solidedge to determine is the tensioner adjustment variable. Where does that tensioner need to be in order to achieve a 185 inch long belt? We'll allow solidedge to run that. You can see that it's adjusting the 2D sketch, which is in turn driving the location of the 3D component. The belt itself is created with an inner part copy to the 2D sketch. And so once the solidedge has determined the location of the tensioner, then solidedge will go back and update the inner part copy to the belt. So I think it's very easy to see this unique and powerful functionality called goalseek and solidedge, and how we can use this for real engineering for these what-if calculations.